So hi there, welcome back. We are moving on to lesson 1 where we actually look at what the objectives for data checking are. Again, we're just going to run through this because we have started checking again. So remember the catfish scenario story we had mentioned where people make mistakes. Now there is the error of omission, and error of commission. Some are deliberate, some were not intentional, some were typos. But whatever happens, there is an impact in the decision making. I told you always data drives decisions, and that's why it's very, very important. It determines in countries whether subsidy should be removed or subsidy should be introduced. It determines people's salaries. It determines how resources are distributed. We cannot overemphasize the importance, but emphasize the importance of data. It's massive. And if you have the wrong data, you will take the wrong decisions. If your fuel tank is saying in your car that your car is full and it's empty, E will be changed to F and F changed to E, you're in trouble. So the whole idea is we need to have credible data that can help us take decisions. So we had already mentioned these 3 qualities of credible data: clarity, completeness, and consistencies. Now I just want you to have a more in this lesson talk about the consequences of not having any of these 3. So let's move on to clarity first. When there is no clarity, you cannot draw you cannot understand what the data is about. So we don't know whether the data is about goats or cows in 1977 or cars in 2020. It's not labeled. You just see variables all around. I don't know if you've ever seen that kind of data before, where you're just seeing a bunch of variables and you don't know what they all mean. The data does not have a description. The variables don't have description. Everything is just looking messed up. And because it is not clear, it's difficult to analyze. If I say, oh, measure this indicator, how are you going to measure it if you don't know what the variables mean? If you don't know which variable is which? If I said, for example, in the data, I want you to give me the area of a certain space, and in the data set, I don't know which one is the length and I don't know which one is the height. I just say a variable v1, v2. It will be difficult to calculate area. Okay, let's just assume you even multiply that. But there are certain other variables that you may not know. Is v3 the length, or is it v2? Especially when they have more than one variable. So it's very important to know what is v1, what is v2, what do these variables stand for. So you cannot understand, and because you cannot understand, you cannot analyze. So please don't joke with clarity. Variables to be labeled, value labels to be labeled. Another thing is valuables. We did label definition. My one is yes, your one is male. What happens? So think about it. If you don't even know what all these values stand for, then you'll be in trouble. And because you're in trouble, you cannot analyze. You cannot produce any results. So clarity is super important. And that's why I did the reverse engineering thinking. What happens? What do I stand to lose if my data is not clear? These are the 2 things you stand to lose. So you can't analyze, you cannot interpret. So clarity is non-negotiable. You must have clarity in your data. The other thing is completeness. If the data is not complete, you are supposed to take a census of a school to find out how many people will go with the bus, and less than half of the school has responded to you. You will not be able to draw inference and say, oh, we'll need 6 buses now, because less than the school has done that. So, oh, you cannot. So all the data for everybody must come in. I said, oh, everybody has come in, and now we see that we need 20% of the students need a school bus. So you cannot. And just like the previous one, it's also going to be difficult to analyze if the data is not complete. Now, completeness, I told you, takes 2 things: We must have all the variables we need. We must have all the observations of entities we need. So I'll go back to my length and breadth story. If the length variable is there and is even clear, but we cannot find the breadth variable, we cannot calculate the area. So it must be complete. The key variables for the key indicators must be in the data set. Otherwise, there will be problem. So completeness non-negotiable too. Now let's look at the final one, consistency. So if we are finding data that is quite, I mean, the values are impossible. We are finding someone who is 5 kilometers tall. You know, how do you make any meaningful inference of that? Especially the average height. Nobody can be 5 kilometers tall. You know, and then the results may be misleading because if you do the average, there will be a problem. You do the average. What about data where where you are computing values of temperature and the temperature is just too high for a human being? Then it may be misleading. So these are the reasons why your data must be credible, and these are the reasons why clarity, completeness, and consistency, we cannot compromise on them. So please, the next few modules we'll be doing will be focusing on these three, and we're starting with clarity first. It's very important that we have all these tools that will greatly help us generate credible data that we can now use to draw inferences and take good quality decisions. So I hope this has helped. I will see you in the next video.